This is Group 2B's Formal Lab Report number 3. We had two questions. How does mass affect work done in an object, and will work done calculated by force equal change in kinetic energy? We hypothesized that work calculated by the force will be approximately the same as work calculated by the change in kinetic energy, and increased mass will increase the work done. It was determined that the calculated values differed depending on which method was used. However, the overall trends were consistent, showing that as mass increased, work done decreased.
So for this experiment, we used two IOLabs carts. The cart on the left we pushed into the cart on the right, which started as still. So the cart on the left we pushed at two different velocities into the cart on the right, which was at two different masses for a total of 4 trials. So this is our system schema of the situation. We have the earth, the table, cart 1 on the left, and cart 2 on the right. And as you can see here, there's a lot of different interactions that are at play. But because we're really just calculating the work done on cart 2 on the right, we can just define our system as cart 2. And so the interactions on cart 2 is gravity with the earth, contact with cart 1, and contact with the table. So this is our free body diagram of the situation. And notice that we do include friction in the free body diagram, even though it's negligible for the IOLab carts. So we can calculate work by the force on the cart times the displacement, but it's important to note that the force should be in the same direction as the displacement, which in this case is just horizontally along the table. So really we're just looking at the force from cart 1 onto cart 2 and the force of friction, although we can ignore that one because it's negligible. And then using the work energy theorem, we can also calculate work as the change in kinetic energy, which is the change in 1/2 times mass times velocity squared. And so there all we need is the mass and the initial and final velocities.
We aim to test the work energy theorem using IOLabs. We predicted that an increase in mass will increase work done because of the equation 1/2 mv squared. The track was set up as discussed previously. The stationary cart had varied masses, and the ramming cart had varied speeds. The exact velocity didn't matter because our velocities were proportional to the change in velocity. We obtained the data in graphs for force, velocity, and position from the IOLab software. We used the area under the force displacement to get one work value, which was compared to the other work equation, delta KE equals 1/2 mv squared.
So this is a sample calculation for using change in kinetic energy to calculate work. Notice that we can use 0 in all cases as our initial velocity because the cart was still, so we can really focus on the final velocity for all the calculations.
And this shows a sample calculation of how work was calculated from force versus displacement graphs. The area under the curve would give work, so the curve was superimposed onto paper and shapes were drawn under it. The sum of the areas of these shapes equaled work done on the car beginning at rest. The values calculated from the two equations were similar, but not very close. Overall, you see a trend that with increasing mass, the work done on the object decreases.
The potential problem we ran into was calibrating the IOLab force monitor. We wanted this to be as close to 0 as possible. With a slight variation, it could have potentially thrown off our data. Also, we were unable to use our IOLab graphs in the program and get the area under the curve. We had to take certain points to recreate the graphs on paper. Using this way is still accurate, but could still lead to small variations once area under the curves were taken. Change in velocity is smaller for the cart with more mass. As change in velocity decreases with the heavier cart, work done on the object decreases as well. Work is more closely related to velocity because the value is squared in the equation. Calculating work using two different methods gives different results because of prior limitations that we discussed. We determined that using change in kinetic energies was more accurate.